For our tips, the first one is to pump up the voltage. Most of these chips don't start malfunctioning until you get above 6 volts or so, so we put our power supplies up to 5.9, causing all of our voltages to stay above 4.
Right on. Alright, so, yeah, our next debugging hint, as it were, is to have meDEWsa Simulator and someone who can run it and walk through the microcode proficiently, running with the hardware debuggers at all times. That way, when you start up your computer from scratch, you can watch your opcodes being processed and then also watch MPC or your MUX register to make sure it's jumping and going to the right addresses.
Check your wiring. Be sure everybody's on the right page with wiring colors, and especially with the buses where most significant and least significant bit are. Important.
Also, most importantly, is make sure you make a new timing diagram every time anything goes wrong. I think we went through 5 or 6 of those.
You can do the next one too.
And also, if the problem isn't wiring, if the problem isn't timing, it's probably propagation delay. You may have had people tell you that you get bad chips, but that only happened to us once. We only had a bad board once. We never had any broken wires. If there's a problem, it's either wiring, timing, or propagation.
So I'm going to talk to you about the simulator. Even though we have this done for so long, I'm still very tired. The simulator is an invaluable piece of software to have both in writing your application to get it ready for hardware and then in debugging hardware itself. The one program by Simon Weaver is very nice, but it has a lot of shortcomings. So if you have a pretty proficient programmer who can write a new one, that would be good. But Simon's works very well if you can't. Some of the problems are keyboard inputs, like when you hit Shift and there's another key, like, I forget.
Enter
but
doesn't work. Enter.
Shift, well no, Enter, I'm getting to that, guys. Shift sends a character in Simon's, but it does not in hardware. For the dumb ASCII terminal, it doesn't send anything for Shift, so you have to take that into account. The return on the dumb ASCII terminals, it sends a 0D. On Simon's, it sends a 0A. So you have to take that into account when you're debugging both for the software and debugging hardware. And it crashes a lot, so prepare to be frustrated.
Okay, we worked on application program, and basically it's working fine. Everything is working, and I think we have some stuff added to. We have a lot of things added to the application program that is even doing more than it's supposed to be doing, and I think Spence is going to tell us about that.
Okay, so yeah, it's working in the hardware now too. We added a cool picture of a nice meDEWsa lady from ASCII art, which is a nice touch. And we got the addition and subtraction working, but we went ahead and added multiplication and division of some sorts. It works, but it's not as flexible as we like it. But it's there, and we just kind of implemented that.
Calm down, Spencer. I know you're
yeah,
excited.
Yeah, I am. Pretty quickly. And
How about you did it in one night?
we did it in one night because we had help from the hardware team, a guy who basically broke it down into C++ statements, and then we took it from there and put it into opcodes.
So it works.
I'm fired up, yeah.
It works!
Jump.
No, James.
So, Spencer and Antoinette, have you added any opcodes?
No.
Okay.
We used the original one. We changed one. We didn't ask for any except for an alteration of one.
What opcode did you alter?
Get C. That automatically put it to the screen, and we didn't want that feature.
Okay.
We took the get C, and we didn't want that feature of putting it on the screen, so we had microcode people get rid of it.
We're the team that worked on the microcode, and since the last taping, we switched back to Simon's microcode because it worked better than what we had planned for. And we just made a couple of changes, and Sean is going to talk about that.
Yeah, we just made a couple very minor changes with assigning the registers and the other change was for the application program, we didn't want getchar to be outputting automatically, which is how Simon had it set up. So we switched that and spent about 6 hours trying to condense the code and pulled out a good 16, 20 lines or so and really brought it down and realized it didn't work in the condensed form. That's about it.
Any reason for that?
We were accessing different parts of it through 2 different places. I didn't realize we were accessing it from one of them, so it worked in one case my way, but it didn't work in the other case. So, yeah.
That's specific.
That's pretty good.
So we're going to talk about group leaders. You guys might want to key in on what we're going to talk about, some things we ran into. One thing for software is definitely teach a couple hardware guys or gals, whatever. Teach somebody on hardware, software, not as in depth as you get into it, but some people on hardware need to know software in case software people can't be there for debugging sessions.
That's going to be very helpful because when you go through debugging, as I've said earlier, it's impossible to understand what's going on in your hardware if you don't understand how the microcode is assigning values to the right places. Another thing as team leader that we've ran into that is going to be important for the future is trying to understand that working in shifts with 2 or 3 people on hardware is probably not the right way to go. And the way we always attacked it on our team was having a time when the whole team met, wired up at the same time. We did it all the way through LogicWorks when we were designing our circuits, and then when we went into the final actual wiring implementation, all the teams were there at the same time. So when problems would come in, we'd bounce ideas off each other, and that was critical and a key point.
It's always good to have software there at the same time as well.
Yeah.
Just
For the
for the team
point.
and for team.
Yeah.
Another thing that I found for hardware actually was the guys, when they build their individual parts, are going to be very protective of them and say they work perfectly. You're going to have to deal with that. It's just be like a father, a petulant child.
Kicking the ass.
Just pat him along and say, well, maybe not. It's okay that it doesn't work.
Yeah, you get to be the devil's advocate as a team leader and flaunt that, because it's going to ask questions. You might be able, if you do that, you might be able to ask a question in good faith and maybe bring up a point that might fix the problem. Even though you might not have the in-depth knowledge on each board, you will get to a point where you understand the entire computer probably at a faster point than when everyone else gets there, because of your when it's being designed, you have to go around and make sure that everyone is considering different things for that when it finally comes together. How is this going to work with this? How is that going to work with that? And make sure that you know those kind of things going into when you start debugging.
That's the same for software. Team leader, don't try and do everything. Well, what I did was I had 2 people working on each section and talk to them regularly. I would get in and help with it, but I wouldn't try and do it all myself. Definitely get a broad understanding of everything that's going on.
Also, don't be afraid to pull all-nighters a lot, because as our team did, our last week, we also, if this hasn't been made clear in the video yet, we are done a week ahead of time. And that is a result of our team putting in ridiculous amounts of hours the week before. Probably over the 2 weeks that we spent building the final computer, I say on average our team spent about 50 to 60 hours, and in some cases over 70 hours on this project. So don't be afraid to put the time in, because the result is well worth it.
Feels good.
Make sure you have happy wires. Happy wires make happy people.
That was pure bubbly.